Welcome back to the deep dive. Today, we're really focusing in our mission to figure out why you'd need something quite this specialized. A communication device promising, well, secure voice comes across basically an airport hangar footprint. We are digging into the EnGenius DURAFON-SIP-BU base unit.
Yeah, this definitely takes us into the deep end of enterprise communication. We're a long way from your typical home router here. This unit, it's really the backbone infrastructure. It lets huge organizations, think warehouses, university campuses, maybe sprawling resorts, maintain a truly long-range wireless network. It's a base station specifically built to slot into existing, modern VoIP systems, uses the standard SIP protocol.
Okay, and this is where it gets, well, pretty wild for me. The range. The specs say this base unit gives you a secure wireless signal up to, wait for it, 250,000 square feet. Or, if you're talking vertical space, it punches through 12 floors. Your standard office Wi-Fi just, well, I can't dream of doing that.
Exactly. And you have to think, in those huge places, massive logistics centers, big manufacturing floors, you've often got tons of metal racking, heavy machinery. That stuff just kills a normal signal. That's why this system relies on the secure 900 MHz band. That frequency is much better at penetrating walls, obstructions, compared to higher frequencies like 2.4 or 5 gigahertz.
Right. And you mentioned FHSS frequency hopping spread spectrum. For those of us not, versed in military-grade comms standards, what's that technique actually doing?
Okay. So that's really the heart of its resilience. This tech essentially scrambles the signal very rapidly. We're talking 100 times every second. That's the hopping rate. Now, this does two key things. One, it makes the signal incredibly difficult to intercept or jam, serious security. Two, it drastically cuts down on interference and crosstalk. And when you combine that hopping with the, well, frankly, enormous number of 65,536 system IDs, you get a really private, really rugged network, perfect for secure places like hospitals or government buildings.
Security, ruggedness, clearly key design points. I also see it's built tough for different temperatures, 32 to 122 Fahrenheit. But there's this other label, TAA compliant. What does that actually mean for someone buying it?
Right, TAA compliance. That means it meets specific U.S. government purchasing rules linked to trade agreements.
Yeah.
So if you're sourcing for, say, military contracts, federal agencies, or certain sensitive projects, that TAA label is often non-negotiable. It just underlines that the whole unit is engineered for institutional level reliability, not just basic functions.
Okay, makes sense. So resilience is paramount. How does it handle call volume in these massive places? I see this single base unit supports 10 SIP accounts. That feels substantial. And during busy periods, it can juggle up to 4 simultaneous SIP calls, or interestingly, 3 SIP calls plus 1 old school PSTN line call.
Yeah, that multimode ability really shows its role as an integration piece. It bridges the old and the new, you could say. And you see that in the ports, too. You've got your standard RJ45 for the VoIP network connection and an RJ11 jack for that traditional phone line, PSTN. But don't overlook a really practical feature, the built-in two-way intercom, essential for quick private team chat across that huge area without tying up the main phone lines, the instant coordination on a factory floor.
Got it. So definitely specialized hardware for places where, downtime is just not an option, which brings us naturally to the cost. It's listed at $1,353.86, sold through global specialists like HDTV Supply, that price tag. Why is that justifiable?
Well, it really comes down to the cost of failure. In these environments, reliability isn't a luxury. It's fundamental. Think about it. If a cheap $50 consumer phone drops a call in a giant distribution center, maybe you lose a minute, maybe some efficiency. Annoying, but okay. But if a critical call fails on a huge, say, 12-story campus network using this system, the cost of operational disruption, safety implications, it could be exponentially higher.
Yeah.
So you're essentially paying for that rock-solid 900 MHz stability, the security, and the guarantee it integrates properly into complex enterprise VoIP systems reliably year after year. It's an investment in operational continuity.
Okay, so zooming out, this deep dive really highlights this very specialized niche, doesn't it? Robust, long-range communication that manages to blend, well, reliable, almost old-school 900 MHz radio tech with today's complex digital VoIP needs.
Precisely. The real cleverness, I think, is bridging that huge physical range covering vast areas with the kind of split-second digital timing needed for modern networks.
Yeah, which leaves me thinking about something for you, our listener. to consider. The engineering challenge here isn't just throwing a voice signal hundreds of yards. That's hard enough. It's ensuring that signal arrives with the absolute digital precision down to that 100 millisecond TDMA frame length mentioned in the specs needed to mesh perfectly with the internet-based systems. How do you balance that immense physical reach with such unyielding digital timing? Quite a feat.